Hello friends, in this video I am going to discuss about point function and path function, quasi-static process, and different quasi-static processes such as isobaric process, isochoric process, isothermal, and polytropic process. State can be taken from initial state point 1 to final state point 2 along many quasi-static paths such as A, B, and C. The area under each curve is different, and also the work involved in changing the state from state point 1 to state point 2 along different quasi-static paths is different. So here the work depends on the path that is followed by the system. So here work is a path function, and it is an inexact differential or imperfect differential. But the macroscopic properties are point functions, and the difference in values from initial to final state depends on the initial and final values, and they are independent of the path that is followed in changing state from 1 to 2. They are called point functions, and they are perfect and exact differential. And here integration from v1 to v2 dv is simply equal to v2 minus v1. Here v2 is final value and v1 is initial volume. So here in this case the change in volume depends only on the initial and final states irrespective of the path the system follows. But whereas work done in a quasi-static process depends on the path that is followed, and they are inexact and imperfect differential. So integration from 1 to 2 delta W is not equal to W2 minus W1. Instead, it is integration from 1 to 2 delta W is equal to W from 1 to 2. To understand the quasi-static process, let us assume a piston cylinder arrangement which has a certain quantity of gas. The piston, the force exerted by, pressure exerted by the gas is balanced by the weight which is placed on the other side of the piston, and which, when the properties pressure and volume are plotted on the graph at state point 1, it is in thermodynamic equilibrium with properties of pressure P1, volume V1, and the temperature T1. And now when the weight is removed, because of the unbalanced force, the piston moves upwards and hits the stops, and it reaches once again thermodynamic equilibrium where the properties are pressure P2, volume V2, and temperature T2, and the path that is followed in change of state from 1 to 2, the intermediate points are not known in this case, and to have the exact work involved in change of state depends on the path that is followed. So to have the exact path, the single weight is replaced by a small different weights, and if the initial state is plotted on the graph with pressure P1, volume V1, and if one of the weights is removed, the piston moves upwards and reaches thermodynamic equilibrium with pressure P2 and V2, and if it is plotted on the graph, the change of state takes place like this. And if another weight is removed, once again change of state takes place, and it proceeds and reaches the final state, and a process in which locus of all the intermediate equilibrium points in the change of state is called as quasi-static process. Infinite slowness is the characteristic feature of this quasi-static process. At every point it reaches thermodynamic equilibrium, and this quasi-static process is a reversible process. And the different quasi-static processes are isobaric process, the process in which the pressure is constant. Here the microscopic property volume is changing, but pressure remains constant. It is changing from state point 1 to state point 2, volume changing from V1 to V2. In case of Isochoric process, that is also called as constant volume process, where volume remains constant, but the property pressure changes from P1 to P2, and the line which is shown on the graph is perpendicular to the volume coordinate. And the next one is isothermal process, that is also called as constant temperature process. In this case, the product of pressure and volume remains constant. Here the property values of pressure and volume are changed, but their product remains same. In this case, the temperature remains constant in change of state from initial to final state. The next process is polytropic process. Here it follows the PV to the power of n equal to constant equation. Here the value of n varies depending upon that different paths are obtained.